Hi, welcome back in this new video. Here we'll see an important topic in machine learning, which is data exploration. So data exploration is very important since it will help us detect some critical issues such as columns with a lot of empty values and also duplicated columns. So the duplication can be identified by running the correlation test in order to eliminate the correlated columns because these columns do not add additional information about how the data causes changes in itself. So let's start by identifying empty values. To identify empty values, we can run this instruction. So the isNull method will check each value in the data frame for null values, and then the any method here will return true if any null values were found. So after running this, we can see that the result is false. The false result means that we don't have any null values. So after running the instruction for checking the empty values, we can now move to detecting the correlation. So to detect the correlation, I created this helper function that displays the correlation between features by color. So let's run this function and apply it to our data frame. So we simply call the function and give in parameter our data frame. So after running this function on our data frame, so the color in this cross plot run from dark purple. It runs from dark purple, as we can see here, with skin and glucose concentration, meaning we don't have a very well correlation between skin and glucose concentration. So as we can see here, we can have the yellow, which means very positively correlated. So since we have the same columns along the horizontal and vertical axes, so we have a horizontal axis here and vertical axis here, we expect the yellow squares on the diagonal from upper left to the lower right here. Since we are trying to have a correlation between a feature with itself, which is normally comparing the feature to itself. So it's obvious that we have this high value of correlation. So, but what about the yellow squares for skin and thickness? The value we have in here, we have skin and thickness in here. We can see that the correlation is very high. We have a strong correlation between these two values. So let's check the corresponding correlation values for each color in the graphic and see just how correlated the skin and thickness columns are. To do so, we can run the core function applied to our data frame. So after running, we can have the corresponding correlation values for each color we saw in our graphic here. So as I previously mentioned that we can notice the 1.0 running down the diagonal table. We can have here 1.0, 1.0. We can have those value running from the diagonal table. Again, this is because we are seeing the correlation of each column with itself. For example, number of pregnancy with number of pregnancy, the correlation is 1. We have here also glucose concentration with itself. The correlation is 1, and so on until we get it this value here, diabetes and diabetes. So by looking at the diagonal, we can see the correlation value, which is 1. So what about skin and thickness? Skin and thickness, we could see the code color, which is yellow here, and we can see that the corresponding correlation value is 1, which means that there is a high correlation between skin and thickness. So we can either make notes of this and make sure we try to avoid using both columns at the same time. In the next video, we will see a powerful technique called feature engineering. So the feature engineering will help us deal with such a problem, because in having features that moves together adds no additional information, which is the case of skin and thickness. Using skin and thickness in our machine learning model will not give us additional information. So we'll need to drop either skin or thickness column. So see you in the next video in order to explore this feature engineering concept. Goodbye. See you in the next video.